This is the Module 3 Water Use and Conservation lecture. Let's start by acknowledging the fact that less than 1% of the Earth's water is available for human use. The rest is salt water or so badly degraded that we can't consume it. 8% of the world's water is used domestically. That means in the home or in buildings. 70% is used for irrigation. 22% is used for industrial processes. So I just want to note that this lecture will be about the 8% of the water that is used domestically. We're going to talk about water use in buildings and in landscapes. In the food module, we will talk about water that is used for irrigation for agriculture, which is most of the 70%. We'll talk about water used for industry in the products, in the resources and products lecture or module, sorry. So looking at water use in the building, we are very privileged in the US in that we have access to clean water at home. We can turn on the tap and water comes out and we can drink it, and we can rest assured that in 99.9 areas, 99.9% of the US, that water is safe to drink. We can also jump in a hot shower. We can flush the toilet as much as we want. So we're very fortunate, but with that comes some responsibility. Let's look a little more closely at our water use. And here you can see the blue drops are 1 gallon of direct use of water shown, and the green drops are indirect use. So let's look at, for instance, hamburgers here. If we go out and we get a hamburger and fries and soda for lunch, that uses approximately 1,500 gallons of water for your one meal. Beef uses a lot of water, as you can see. And that 1,500 gallons of water, just to give you an idea of what that is, that's about enough water to fill a small swimming pool. So you can see from this diagram that a lot of water use is hidden. It's behind the scenes. We do not see the water that's being used. Obviously, we see the water used in our showers and in our toilets and in our sinks. We can dial those back a little bit, use a little less, take shorter showers. But the reality is other decisions that we make impact our water use. So let's pause for some definitions here, just so we're all on the same page. Potable water is water that is safe to drink. The water that comes out of our taps or even flushes our toilet is potable water. Gray water is the relatively clean wastewater from baths, sinks, washing machines, and other kitchen appliances. This might have little pieces of food in it. It might have skin or hair. We would not want to drink it, but it's relatively clean in that it doesn't usually contain pathogens. And so we can reuse this for other uses like flushing toilets or irrigating landscapes. Black water is wastewater from toilets. This is water that needs to be treated quite a bit before it becomes usable for any other use, because it can usually, it may, not usually, it may contain pathogens. So in water conservation, we've made a lot of progress on low flow fixtures. These are fixtures like sinks and shower heads and even faucets that don't run as much water through them. So a normal toilet, for instance, flushed 30 times a day, will use 66,000 gallons of water a year. A low flow toilet flushed the same number of times will only use 18,000 gallons a year. That's a 73% reduction, which is substantial. So low flow fixtures are good, but they're not quite enough. And so we're going to explore some strategies that really focus on conserving far more water than just low flow fixtures. So there's a new goal in sustainable buildings and in sustainable sites called net zero water. This is where you meet all the needs of a building through what falls on the building or on the site. You also manage all wastewater and stormwater on site. So this is a bit of a complicated diagram, but let's just walk through it, and I'll try and walk you through it with my cursor. So rainwater falls on the roof of the building, and it's this green line. It gets piped down and is treated and held in a potable water tank because it's treated enough that it becomes potable. We'll talk about that in just a minute in a future slide. Then as it gets needed, it gets pumped back up to sinks, kitchen sinks, etc., and it's drinkable water. After it gets used in the sink, it's considered gray water. So, or in the shower, it's considered gray water. So then it gets carried down and treated in a different treatment process in the basement of a building. And then it gets held in a non-potable water tank. Very often, different colored pipes will be used within a building to distinguish potable water pipes from non-potable water pipes. Then, as it's needed, it will be used for irrigation in the landscape, or it will be carried up to flush toilets. The water from the toilets then is black water. And this is water that then has to be run through a septic system and gets returned into the groundwater after it runs through the septic system and replenishes the water table. So this is a great diagram, and I'll provide the lecture so you can go back and look closely at it, but this is what net zero water means. So the first strategy that we're going to talk about is rainwater harvesting, and this is where water is collected off the roof of a building. And rainwater collection systems can cut potable water use to a fraction by using rainwater to flush toilets or to irrigate. In most cases, using rainwater for potable water is against regulations, unfortunately, in most parts of the United States. There are some areas that do allow individual homeowners to capture their own rainwater for drinking. In addition, there are a few buildings and even some small communities that capture their rainwater due to them being in remote locations. But the laws are changing, and so look for in your lifetime rainwater harvesting as a possibility for potable water. This is the Hitchcock Center for the Environment, which is a Living Building Challenge certified project. We'll talk about the Living Building Challenge as a very rigorous example of a rating system for sustainable buildings and landscapes more in our building module. This is in Amherst, Massachusetts, and the roof forms were designed in such a way that they would capture the rainwater and funnel it to cisterns. You can even see this little bike rack in the landscape is funneling to a rainwater barrel there. So within the building, the rainwater is held in these tanks. And since this is an education center, they're showing visitors what the water is like in the tanks. The first flush of the rainwater, the first quarter inch of rainwater that falls, gets released into the landscape for irrigation because it's considered to be the dirtiest. After that, the rainwater is held in these tanks and reused for flushing toilets in the building. It's reused for a fire suppression system, should that ever be needed. And also it's used for irrigating plants. Water that isn't used makes its way out to a constructed wetland and gets cleaned and returned to the groundwater. So it's important to pause here when we talk about rainwater capture and understand that some states actually outlaw or severely restrict rainwater capture. The states that restrict it, you can see, are in the lighter turquoise blue, and it's no coincidence that these are the drier states. And in particular, water from Colorado and from the Colorado River is sent in an aqueduct all the way for use in California. So California has, and California pays for that water. So Colorado does not want people to capture water. They want to let it go to California, where the users in California are paying for it. So there's the whole downstream issue. If you capture water, people downstream from you who might have agriculture going on don't get the water that you capture and reuse. So, so that's why it is restricted in certain states. It is unrestricted in North Carolina and the states that you see in dark blue. And in fact, California, Oregon, and Washington are really on the forefront of capturing rainwater and reusing it. So here we see the highest profile building in the US that does capture rainwater and treat it enough that it becomes potable water. So what they, this is the Bullitt Center in Seattle. It is also Living Building Challenge certified. The architects are Miller Hull. The landscape architects are Burger Partnership. The engineers are 2020 Engineering, Water, and Plumbing. They all collaborated together with regulators at the city to not just the city, but the city, the county, and the state to be allowed to treat the water that they capture, the rainwater that they capture, and have it be potable within the building. So here you can see the diagram of how that potable water works. Water falls on the roof, gets held in a cistern. Some of that water is drawn out and filtered. And then it's disinfected with UV light, injected with chlorine, and held in a potable water tank. And then it's drawn off into the sink and drinking fountains, to the shower, to the dishwasher. All the water that flows down the drain of those systems flows to a gray water system, which we'll talk about in just a minute. Any excess water held in this cistern that isn't used in the building is conveyed to Lake Union via a dedicated storm system. Once again, this is not an inexpensive process because water quality monitoring is required, and it is monitored every single day by a professional wastewater engineer. So this will be a booming business. I imagine that a professional wastewater engineer travels around testing water at any sites that are using potable water. So within the Bullitt Center, we also have gray water capture and reuse. This is capturing water from sinks, showers, washing machines, dishwashers, and it is pumped to the basement of the building and then pumped out to irrigate the green roof that they have and to irrigate some of the landscape beds that they have. They actually have engineered these landscape beds to host plants that are good at removing nutrients from water. So nutrients oftentimes fall in rainwater, and when they get used in certain planted areas, a lot of nutrients are removed from the water, and any groundwater infiltration that happens is with very clean water. So when we talk about irrigating the landscape with gray water, that's great. But if we could reuse gray water in other areas, like to flush toilets and not have to irrigate landscapes, that would be even better. So we can use gray water for irrigation, but it's best if we use plants that are appropriate for a site. They might be native plants. They might be what we call adapted plants. Adapted plants are those that are that have the same water requirements as native plants. They're not invasive. They don't require pesticides or herbicides or insecticides in order to survive. So they're basically no input plants, but they might not be native. So that's the ideal in landscape design, is that we use plants that don't need water after establishment. All plants need water for about the first year of being planted, and then they become established. after about a year, and then we don't have to irrigate them any further. That's the ideal. All right, going back into the building, let's look at a couple other wastewater technologies. Composting toilets are basically aerobic composters, which means that air gets into these composting systems, and they the water is heated to, or sorry, the waste is heated to about 165 degrees, and what this does is it kills pathogens in the waste. And then the waste material gets converted to biosolids, which can be used for composting either on the same site or on a site elsewhere. These systems use 96% less water than a typical toilet. So composting toilets they don't smell. They use very, very little water, and the solid material is converted into nutrient-rich biosolids, which is always a good thing when we're talking about sustainable agriculture. Another method of treating black water is on-site wastewater treatment, called a living machine. This living machine is diagrammed here with the influent coming in here to an anaerobic reactor. This is where air is not let into the system. Then it's pumped into aerobic reactors here. These are tanks that are planted with water that do allow air into the system. And the microorganisms on the plants, the plant roots, and in the soil in these systems takes up the nutrients and the pathogens and that kind of thing. Sludge, excess sludge is periodically removed. All of this happens in a greenhouse. And if you walk into this greenhouse, you'd think, oh, it's going to smell so bad. But no, it doesn't. It smells like a planted greenhouse. It's actually a very pleasant experience. So the sequence, the water moves through these tanks and then finally into a clarifier, which cleans a lot of the sediment out of the water, and then into a constructed wetland. Now, this constructed wetland could be inside or outside of the building. And then studies have shown that water from living machines is actually cleaner than what we call potable water coming from our cities and our counties. But in most cases, one is not allowed to drink water coming from living machines. There are a few exceptions. There are also a few small municipalities that use living machines as their primary wastewater treatment plant, and then they drink that water. Most of the time, though, the water is treated as gray water and used to flush toilets and to irrigate landscapes. So a variation on the living machine is where you have a living machine inside the building, as you can see here. And then you have the wetlands part of the living machine located outside of the building. In this case, at the Omega Center for Sustainable Living, that's what they did. And they used the wetland both for water from the living machine, which is black water that's been treated, and runoff water from the parking lot and excess water from pavements to treat that as well. So constructed wetlands can be combined for those uses, as long as the wastewater has been first treated in a living machine or some other biological wastewater treatment process. So just in conclusion, it's important to point out that these systems are integrated with each other, even though in some cases they're very separate systems. They need to be conceived of with collaborations among multiple professionals: architects, landscape architects, engineers, code officials, policymakers, ecologists, biologists, et cetera. And then very importantly, clients need to be there at the table so they truly understand what they're buying into. And users need to buy in as well, because, for instance, a composting toilet isn't going to work properly unless the user uses it properly. So, all of these folks need to be at the table right from the start with these integrated water systems. But if they are, it can pay off substantially. And at some point, as you've learned from the videos on water that you've watched, we're going to be paying a lot more money for water. And so using rainwater to drink, using rainwater for other non-potable systems is going to be the key to the future. Thank you.